least square method applied to the cooling of a cup of coffee. So what we did over here was at given times we measured the temperature in degrees of a cup of coffee. And we would like to know what's the function of the cup of coffee. Well, probably it would be something like this. The temperature equals a constant times E minus K to the power of T, something like that. Well, these times are not very useful, so we say this is a time 0. What we get over here, if we put in the function here, so is that the temperature is a 74.8 equals C times E minus K to 0. Oh, E to the power of 0 equals C. So we quickly found the constant, which is 74.8. So we take the new formula, which is 74.8 times E minus KT. What we now will do is fill in all these numbers into the function over here. So this is a 4 minutes later. So we have a 67.1 equals 74.8 E minus 4K. Just switch them, but it's no problem. Next one, 60 equals 74.8 E. We'll have a look. This is 9 minutes later. You see 20 minus 11 is 9. So 9K. Next one, 52.1 equals 74.8 E minus, well, that is 15 minutes, 15K, etc., etc. Okay, next step, what we'll do is we divide everything by 74.8. So I get here 67.1 divided by 74.8 equals, well, if you divide something by itself, it will get 1 times E minus 4K. So this will be something like 0.8971 equals E minus 4K. Next one will be 60 divided by 74.8 equaling 1 to E minus 9K, or 0.8021 equals E minus 9K. Okay, I'm interested in the K value, so what I will do here, take the natural logarithm to the left and the right, so ln 0.8971 equals ln E minus 4K, but this is minus 4K. So with using the ln, we get rid of the e power and just get the 4K, and we're interested in the decay value. Okay, next one. So I take the ln over here, so I have a ln 0821 equals, well, minus 9K, etc. Of course, we can calculate these numbers because this is something like 0.1086 minus equals minus 4K. So if we do that with all the numbers, we nicely get a kind of matrix. Try to write it down here. So calculate the ln with the number over here and make it equal to minus the number times k. So I have, for the first calculator, I have minus 0.1086 equals minus 4K. Then I have minus 0.2205 equals minus 9K, etc., etc. So I get something, and the last one will be probably minus 0.7973 equals minus 54K. But here we have a matrix, because this looks like a matrix. Well, I'll switch it around, but I have -4, -9, and at least -54. Where's the 54 coming from? Well, that's this one here. 54 minutes after time 0. Times k, that's the one we're looking for, equals the factor -0.1086, 5, and the last one -0.7973. Okay, well, this is a matrix equation which we could solve. I go over there. Solve. I get something like the k value would be, well, this is the matrix A. This is the factor x containing the variable k equals the factor b. Well, if we solve this, we get something like A transpose times A inverted AT times B. Well, if I do that in my computer or calculator, it gets me something like 0.01683. Well, this is the best fitting k value for this situation over here. Now I have to put the k value into the formula, because we said the temperature at a given time t equals 74.8 times E minus 0.01683 T. Now I'm interested, for example, what will the temperature be at T40? Well, just fill it in. 74.8 E minus 0.01683 times 40, and will give you something like 38.3 degrees Celsius. Have a look. 40 is, well, I have to work back. This is a 46. This is a 36, a 26, and a 20. So minute 40 will be something between here. I have 8. Yeah, could be possible. Now, best thing is that in your calculator or your computer, you just make a graph with all your points, something like this, and then let the calculator plot actually your graph, and it will look something like this. And the idea is that with the function for any time required, you can calculate the temperature given by the best fitting curve. And the best fitting curve is here, something like this exponential equation. Sometimes this line might be so flat you could decide as well to take a straight line, but here we took the exponential function. Okay, thanks for watching.